So I thought maybe we'd look at another example since it seemed to be struggling with the last one.
Let me out of here!
Well, I'm sorry. I was hoping that it wouldn't be too bad if we'd look through it.
Let me out of here!
Well, okay. Well, you know, maybe we won't get too deeply into this, but it shouldn't be too bad. Draw the direction field and sketch a few possible solutions for the differential equation dy dx equals 1 minus y over x. So what we would be doing, we would say, well, 1 minus y over x equals c would be the isoclines, and so let me see what that would look like if I made an equation out of that. And put in, you know what, I think I would multiply both sides by x, and then I'd have c times x equals x minus y. So that actually would be a line. It would be cx minus x equals negative y, or maybe it would be you know, I could actually write it like this: negative c, oops, sorry, this c times x minus 1. Oh, that was an accident. Negative, I'll try this again here, come on now. Negative c times x minus 1, that's what I was trying for, there you go, equals positive y on this side. And so really it's just y equals negative cx plus c. So they're just lines with slope negative c. So on a line with slope negative c, we could then say, well, at the point, let's say x equals 1, y equals 1, x equals 1, y equals 1, you can see we would have a slope of 1 minus 1, or slope of 0. And at the point where x is 5 and y is 10, we'd have 1 minus 10 over 5. Oh, I don't go up that high, sorry. Let x be 2 and y be 4, then we have 1 minus 2, negative 1. So the slope would be negative 1 where x is 2 and y is 4. So if you can see up here, the slope would be negative 1 at about that point. So maybe it'd be more like here. So I think you can see how this is working. It would be painful and it would take far too long to draw this by hand, but maybe we could do 20, 30 by hand without too much trouble. But so anyway, I hope you get the idea. And once the lineal elements are drawn, once we have the slope field drawn, once we have the direction field drawn, I'm using the same different words for the same thing, then we might be able to sketch some probable solutions. And if we had a particular initial condition, then maybe that would say right here, then it would be the solution that goes through that point. So granted, this is a graphical method to solve a differential equation, and all we're going to get out of it is which one of these graphs to use to approximate. But so here is the differential equation solved. Of course, you know, this is just this integrating factor e to the 1 over x dx, so that's e. The ln of x was just x, that's the integrating factor. Multiply both sides of this equation by x, and we have x dy dx plus y equals x. So that means the derivative of xy equals x. Integrate both sides, we got xy equals x squared over 2 plus c, so y equals x over 2 plus c over x. And for any constant c, that would be a descriptor of any of these curves here. You notice there's something like a hyperbola, or maybe a typical graph of a rational function that has an oblique asymptote or something similar to that. But here is that very differential equation with this nice file for MathCAD that will draw the direction field. And here's a much better drawn direction field than this one was. You'll see how tight, you know, the little lineal elements are. Remember 2, 4 had slope -1. We looked at that before. And so the solution of the equation is, as we said, x over 2 plus c over x for any constant c. Let's try a couple, and we'll try to draw a few on our field here. Let's say x over 2 plus, let's just say 1 over x, and then we'll come back and change the 1 to something else. And I think this is an anomaly. This here and this here would be part of that solution. And so if I made it 2 over x, what changes there? Well, it's the same idea. It's this. It looks a little bit like a hyperbola, as you can see. This is a fake. This is a fake. It's like it's drawing in the horizontal and oblique asymptotes. And of course, we know it shouldn't do that, and it wouldn't really do that. But the rest of the blue, like this part and this part, that's legit. Let's say 5 over x. Then you barely see the graph, because like I say, this part's an anomaly and so is this. But right, maybe we'll make it a negative number, -2 over x, and you can see a hyperbola going in this direction, or something a little bit like a hyperbola going in this direction. So would be the solution. And what else? What haven't I tried? -1/2 maybe, huh? -1/2 over x. So there we got this part coming to here and this part going up here. Like to see how this continues, but it might actually hit an asymptote there at x equals 0, and of course you know it does, because if x equals 0, what's this doing? -1/2 over 0, going to -infinity. So of course it has an asymptote there. Let me try to make it +1/2. Probably won't change too much. At 1/2 over x there. That one is again asymptote going this way, because as x goes to 0 from the right, we go up this way towards +infinity, and as it goes to 0 from the left, we go down this way towards -infinity. So hope you can see from this how you can use a direction field to get a possible graph of a solution.
I'm sorry, I can't.
Well, I'm sorry. Maybe go back and watch the videos again. Or maybe you should try something else. Like a lobotomy.